So the SAT math is broken down into 4 categories: algebra, advanced math, problem solving slash data analysis, and geometry slash trigonometry. So you are guaranteed to get some questions within each of these categories. So for this video, I'm going to tell you very common problems that are bound to show up on every single SAT, including the SAT this August. So this question is a good example of everything to know about slope for the SAT. Alright, so let's begin by saying, what is slope? Slope is what people usually call rise over run. What this really means is the change in y over the change in x. In other words, what is y2 minus y1? The difference. What is x2 minus x1? The difference between 2 points. And we could write the equation of any single straight line, like these two here, as y is equal to mx plus b, where m is the slope and b is your y-intercept. And the y-intercept is something that is given to you when you have 0 on the x-axis. So just look at the x-axis, go to 0, and move up along the y-axis. And these points, those are the y-intercepts. And we could also solve for this equation by plugging into this format: y minus y1, which is some point, equal to m, our slope, times x minus x1, the x-coordinate of the point that we used here at y1. So this question is asking us for the system of linear equations shown here, which is just the equation of this line and the equation of this line. Let's start by finding the slope of our top line here. So the slope is y2 minus y1, so we need 2 points on our line. So we could pick this one here, because we know exactly where it is. It's 3 and 4. And go pick this point here. It's 8 and 0. So slope is our y2, and we have to pick this as y2 because it's further along on the x-axis. So y2 is 0, and y1 is 4. x2 is 8, and x1 is 3. So this gives you negative 4 over 5 as our slope. But what's b? What's our y-intercept? Well, like I said, it's just anywhere on this line where x is 0. That's our point, and it's only going to happen at one point. In this case, it's about 6.4. So b is 6.4. So you just plug everything into this equation right here, and we have the equation for one of the lines. Y is equal to negative 4 over 5x plus 6.4. So let's keep that handy for now. So let's solve for the equation for the other line, the one on the bottom, using the other equation that I told you about. This one right here. You could do it the same way that I just showed you, but we're going to use this one just so you could have it in your toolbox. So let's start by finding the slope. And we need 2 points for that. So let's pick this one, and let's pick this one. That way we know exactly what they are. So this is 8, 0, and this is 3, 2. So y2 is 0 minus y1, which is 2, over x2, which is 8, minus x1, which is 3. So this gives you negative 2 over 5. And I know we could find this line the exact same way we did before, but just so you're aware, let's do it this way, using this equation. So y minus y1, let's just pick anything. Let's just pick this point right here. So y1 here is 2, equals m, which is our slope, which we found to be negative 2 over 5, times x minus x1, which still has to be this point, so it's 3. So you get y minus 2 is equal to negative 2/5 x plus 6 over 5. And let's move this 2 over. So we add 2 to both sides. Y is equal to negative 2 over 5x plus 6 over 5 plus 2. But we want everything in terms of fractions, and we know that 2 is also the same as 10 over 5. So y is equal to negative 2/5 x plus 16 over 5. Okay, so that's the equation of that line. But hang on, that doesn't look like any of the option choices. Right, that's because the SAT, they want to trick you. They want to put everything in this format with x and y's on the left and constants on the right. And they also want to remove all decimal points and all fractions. Alright, so let's just start with this equation. So let's move everything to one side for variables and everything to one side for constants. So moving this 4/5 x over, we can have 4 over 5x plus y is equal to 6.4. And if we multiply everything by 10, then we can get rid of this fraction and match it to something on this side. And how do I know to multiply everything by 10? Well, because I'm looking at the answer choices. This is 64, this is 64, this is 64, this is 64, this is 6.4. So if you multiply that by 10, then you will match what we're given here. So multiply both sides equations by 10 in order to keep equivalency. So we'll have to put times 10 here and times 10 here. So working that out, you get 40 over 5 x plus 10y is equal to 64. So that means, simplifying this, you get 8x plus 10y is equal to 64. Now, does that appear in any of our answer choices? Well, almost, because we have negative 8x, negative 10y, negative 64. So that means that we could multiply this whole thing by negative 1 on both sides of the equation and get some equivalency to match this. So negative times 8x plus 10y equals negative 64. So that means negative 8x minus 10y is equal to negative 64. And the only answer for that is D. So we don't even have to do this one, but we'll do it just for practice sake. So move everything to one side. So move this here. You get 2/5 x by adding that term, plus y is equal to 16 over 5. And if we multiply this whole thing by 10 also to match up with what is given to us in our answer choices, then we can get 10 times 2 over 5 x plus y is equal to 10 times 16 and a half. 16 and a half is also 3.2. So you have 20 over 5x, which is the same as 4x, plus 10y is equal to 32. And that matches D also. So we know that's our answer choice. Okay, so another very common problem that the SAT asks you is they want you to find the slope of a perpendicular line. And that's easy, because the slope of a perpendicular line is just the negative reciprocal. It's just negative 1 over m of the original equation. And well, why is that? Well, because let's say I have some line here like this, and some other perpendicular line here. Perpendicular means that there has to be a 90-degree angle. So that means the slope of this line has to be opposite here, being negative, and inverted to go in the other direction. And that's why it's the negative reciprocal. So we're given this line, so 3y plus 12x is equal to 5. Well, how do you find the slope from this equation? Well, we told you up here. All lines can match this equation, y equals mx plus b. So we just need to put it in the form of y equals mx plus b to find our slope. So it's just simple algebra. 3y is equal to negative 12x plus 5. Y is equal to negative 12x over 3 plus 5 over 3. So our slope, m, is equal to negative 12 over 3, which is the same as negative 4. And the slope of a perpendicular line, it has to be this, is the negative reciprocal. So it will be negative 1 over negative 4. And so the answer is 1/4. So every single SAT asks for a system of equations, and those are easy. You can just plug those into decimals and see where those lines intersect, and that point of intersection is your answer. So this question is a different case. It's saying that there is no solution to this equation, and we need to find some random constant p. Okay, so what does it mean when there's no solution? Well, like I just said, if you have a system of equation with a solution, that point of intersection is our answer. So that means that we need to find p in such a way so that the point of intersection never happens. And the fastest way to do this is to go into decimals. So to solve this in decimals, all you need to do is just write the equation that we're given. 3 over 2y minus 1 over 4x is equal to 2 over 3 minus 3 over 2y. And type in the next equation. 1 over 2x plus 3 over 2 is equal to some constant p times y, and let's make a slider for p, because that's what we're looking for, plus 9 over 2. And look, we have a point of intersection. So if this question was saying, what is the solution? That's the solution. 7.73 will be the x-coordinate, and 0.867 will be the y-coordinate. But we're not asking for that. We're asking, when is there no solution? So we just have to keep moving p and playing around with it until it never has a point of intersection. And as you can see, the more positive we go, we start to get to a point where those lines are parallel to one another. P is equal to 6. They look perfectly parallel to one another. There's not a single point of intersection, which means the answer to our question here is P is equal to 6. And that's it. That's all we need to do. Now, a very common problem on the SAT, which you're most likely going to see, is to be able to write an equation in terms of another, or solve for an equation in terms of another equation. So in this case, we have some equation here and some equation here. So we need to find what is A and what is D and add them together. So let's start by rewriting the problem. X squared plus 6x minus 7 is over x plus 7 is equal to ax plus d. And if you look at this quickly, there's no way you're going to find some number for a and some number for d. There's just no way. There's just too many unknowns. You have some unknown a here, you don't know what x is, and you don't know what d is. So there's no way you're going to be able to separate these and find one. So the trick is you need to be able to rewrite these equations. So notice that this looks like something you could factor, doesn't it? Something that can multiply to -7 and add to 6. And so what is that? Okay, what multiplies to -7? You have -1 and 7. And what adds to 6? Well, -1 and 7. Those add to 6. So we could rewrite this equation, x minus 1 times x plus 7, factoring it out using the AC method, divided by x plus 7 is equal to ax plus d. Well, look, this cancels out. X plus 7, this cancels. So what we're left with is x minus 1 is equal to ax plus d. And saying, what is the value of a plus d? Well, this matches, doesn't it? Because you have some invisible 1 here. So that means a is equal to 1, because 1x, ax, and then d is equal to -1. It's like plus something, plus -1. And it's asking for what is a plus d. Okay, so 1 plus -1 is 0. And again, on another example, the SAT is usually asking you, can you rewrite some equation in some other form? And so this one's just testing your exponent rules. So you know that the square root of a times the square root of a is equal to the square root of a times a, which is the same as a squared. So if we have the square root of a plus c cubed times the square root of a plus c, that's the same thing as saying a plus c cubed times a plus c, all under the square root sign. So putting this together, you have a plus c to the 4th power, and that is just a plus c squared. So let's just expand this out. It's a plus c times a plus c and FOIL it out. So we have a times a is a squared, and then a times c is ac, and then ac again, and then c squared, which is the answer is c. And you can do this in Desmos by just typing it in. So the square root of some quantity a plus c all to the 3rd power times the square root of a plus c. And you make a slider, a constant slider for all of them, and then just type in all your answer choices. But we know the answer is 4. You have 4 here and 4 here, so you know that that is the answer. And the SAT loves to ask questions about nonlinear functions, functions that are not just a straight line. So for this equation, we're said that g of 7 minus w is 0. Okay, so we just got to plug in 7 minus w into this equation. So g of 7 minus w, we just plug that in for x, is equal to x, which is 7 minus w in this case, times x, which is 7 minus w minus 2, times x, which is 7 minus w plus 6 squared. What is the sum of all possible values? Okay, well, first we need to find what is w, and we know that this is equal to 0. So we have 7 minus w minus 2, which is the same thing as saying 5 minus w, saying 7 minus w plus 6, which is the same as 13 minus w squared, is equal to 0. And so anything times 0 is 0. So that means 7 minus w equal to 0 is an answer, which means w is equal to 7. 5 minus w is equal to 0, which means w is equal to 5. And then 13 minus w squared is equal to 0, which means w is equal to 13. So that's all the answer choices for 13. And it's asking for the sum. Just add them all together. So that is 25. And College Board loves to ask word problems. And they also usually do some type of conversion factor. And so this is how you would do questions like this. So first, read the question carefully. A vehicle is going 7.3 meters per, so we do divide by something, some ratio, per second squared. And this is in meters. What is this rate in miles per minute squared? Okay, so what you can do here is you just need the units to cancel. So we want to get rid of meters. So we have to divide by meters. But what do we want? We have to replace it with something. Well, we want miles. So let's put miles up here. And we're told that 1 mile is 1,609 meters. Okay. But we also want to get rid of seconds squared. So we got to multiply by seconds here. And what do we want? Well, we want minutes. And you know that there is 60 seconds in 1 minute. But this is seconds squared, which means that this also has to get squared in order for this squaring to cancel. And you just work this out. And so you get 16.333. So the answer is 16.3. So you may get a question on the SAT relating to circles. And so this question shows you a lot of information you need to know. So let's start with the basics. We know that the radius is from the center outwards to any other point on the circle. That is the radius. And you know that the diameter is from one end to another end, from one end to another end. And you know the circumference is the distance all around the circle. It's kind of like the perimeter of a circle. Okay, so for this question, and we also know that the inside of every single circle is 360 degrees. So we're going to need to know all that knowledge to answer this question. Okay, so let's start. We're told that the circumference is 144 pi, and it's telling you that the length of this arc is 2 times that of the length of this arc. So fundamentally what we're solving for is the length of an arc. So what is the equation for that? The equation for that is 2 pi times the radius times theta, theta being the angle of interest, which is the angle pointing at the arc that we want. So since we want the arc QR, you have to find theta on this area pointing towards it, over 360 degrees. All right, so let's start. Well, how do we find the radius r? Well, you know the radius is half of the diameter. But how do we find the diameter? Well, we're given the circumference. Circumference is pi times diameter. So we know that 144 pi, our circumference, is equal to pi times the diameter. Pi's cancel. Our diameter is 144. And what's our radius? Our radius is 1/2 the diameter. So that means our radius is 72. So plugging this in, we have 2 pi r, which is 72, theta over 360 degrees. Okay, well, how do we find what theta is? All right, so let's clean this up a little bit. You know that every single circle has to add up to 360 degrees. And based on the equation of an arc, 2 pi r theta over 360, we know that since this arc is twice the length of this arc, PQ, the angle must also be double. So if we write this out as saying that this angle PQ is x, and this has to be double, so it's 2x, we're halfway there. Now, how do we know what this and this is? Well, when you have angles intersecting like this, you know that the angle here is equal to the angle here, and the angle here is equal to the angle here. So that means that this is x, and this is 2x. And all circles must add up to 360 degrees. So 2x plus 2x plus x has to equal 360. So that means 6x is equal to 360. X is 60 degrees. So now we have all the information that we need. So we just plug everything at 2 pi times 72 times theta. And our theta is 2x. So that's 120, 60 times 2, over 360. And plugging all this into a calculator, you end up with 48 pi. And you're most likely going to get a question about similar triangles and right triangles and trigonometry and all that jazz. So we're told that you have some triangle ABC, which is similar to some triangle DEF. It says C and F are right angles, so C and F are right angles, and A corresponds to D. That means B corresponds with E. And we're told that tangent of A is equal to the square root of 3. So what's tangent? Tangent is opposite over adjacent. So since we're looking at it from this angle, well, the opposite angle from A is here, CB, and the adjacent angle is here, AC, and that's root 3. And we're also told that DF is 125. And we want to know what is DE, the hypotenuse here. Okay, well, similar triangles have a relationship with one another. So the ratios of each side is equal to one another. So that means the length of AC over the length of CB is equal to the length of DF over the length of FE. Okay, so now that we know this, we know tangent is opposite over adjacent. So that means the length CB over the length AC is equal to the square root of 3. And we just said that there's a relationship between the ratio of sides. So that means the square root of 3 is equal to the corresponding section CB, which is FE, over the corresponding section of AC, which is DF, which we're told is 125. Alright, so let's solve for this. The square root of 3 is equal to the length of FE divided by 125. So that means 125 square root of 3 is equal to the length of FE. So let's draw this out. So you know this is F, this is E, this is D. and we're told that this is 125, this is right angle, and this is 125 square root of 3. Now notice something. Notice that this looks like a special triangle rule. A 30, 60, 90 triangle has the relationship that this is x square root of 3, and this is 2x, when this is 90, this is 60, and this is 30. So you could use the Pythagorean theorem, a squared plus b squared is equal to c squared, and c is equal to the square root of a squared plus b squared. Or you can use the special triangle and recognize that we have x root 3, and just 2x is just 125 times 2. And so that gives you 250, which means the answer is D, 250.